So let's look at an example. Use this formula to find the area bounded by the x-axis and y equals x squared, subtract 2x. So good idea to know what that graph looks like. And here we go. Even though I've copied the solution there, I'm going to work through it step by step on my own so you can see lots of steps in there and understand the steps. So the curve cuts the x-axis at y equals 0. Okay, so we're just figuring out what the graph looks like. Okay, so the first step is we've got this function x squared minus 2x. So to figure out the zeros, x squared minus 2x equals 0. X equals 0 and 2. Okay, so these are our zeros. The way that they've solved this in the textbook is exactly by using this formula here. Okay, the upper curve, subtract the lower curve, and that's what we've taken the integral of. So here we've started it with that formula. The upper curve in this case is y equals 0. And the lower curve is our function y equals x squared minus 2x. Okay, so I'm just going to do all the steps out in that manner as well. So the area from 0 to 2 of this upper curve, which is 0, subtract the lower one, which is x squared minus 2x. And that's my integral. So subtract x squared plus 2x dx. So we get negative x, add 1 to the exponent and divide by that number, plus 2x, add 1 to the exponent, divide by that number, from 0 to 2. Simplify. From 0 to 2. Okay, so negative 2 cubed all over 3 plus 2 squared. Subtract this whole thing again with 0 substituted in. I know that that's going to equal 0, but I will write it here anyway so you know we've actually substituted it in. So we have negative 8 over 3 plus 4, subtract 0. So negative 8 over 3 plus 12 over 3, which is 4 over 3 units squared. Okay, alternatively, back when we looked at the last section, section 19a, and our investigation, we could see that when we have an area underneath the x-axis, we could take the integral of that, which is still our 0 to 2, of just the function, okay? Our upper function in this case that we did up here was our x-axis, okay? But that also could be just our boundary. X squared minus 2x dx. But because it's underneath the x-axis, we can put a negative sign out here. Let's see if we get the same answer. So we'll have negative this integral, which is x cubed over 3, subtract x squared from 0 to 2. So negative 2 cubed over 3, subtract 2 squared, and the other part will be 0. Negative 8 over 3, subtract 4. Negative 8 over 3, subtract 12 over 3. And negative 4 over 3, which is positive 4 over 3. Okay, so interesting to know you know, we already did know how to do this one, but now we did it another way using area of two curves where one of the curves is the x-axis. Both ways work. Example 5. Find the area of the region enclosed by y equals x plus 2 and y equals x squared plus x subtract 2. Okay, so again, good idea to take a look at what these graphs look like so we know which one's upper and which one's lower. So we know what this graph looks like from our quadratics unit. We know how to graph this guy. We could figure out the zeros of it. Okay, so y equals x squared plus x subtract 2. We can determine the zeros. X plus 2, x subtract 1. So x is negative 2 or positive 1. Okay, so there's negative 2. Here's positive 1. Perfect. We also know what x plus 2 looks like when we can graph that. Y-intercept of 2, slope of 1. Okay, now we can figure out our area. So the upper function is y equals x plus 2. And the lower function is y equals x squared plus x subtract 2. Okay, therefore area is the integral from the points of intersection, so negative 2 to positive, no, not positive 1. We need to figure out where those points of intersection are. Okay, so points of intersection. Points of intersection occur where those two graphs equal each other. So x squared plus x subtract 2 equals x plus 2. X squared, x plus x cancel, x equals x cancel. Subtract 4 equals 2. So difference of squares, x plus 2, x minus 2. So x is negative 2 or positive 2. So these are our points of intersection. So here's negative 2, here's positive. That's where our area is bounded. So negative 2 and positive 2 here. Okay, so that's our integral. Upper. So the upper graph is y equals x plus 2. So x plus 2. Subtract the lower function, which is this, x squared plus x subtract 2. And we're taking the integral of that. Simplify here. Subtract x squared. X subtract x, 2 plus 2 plus 4 dx. So negative x cubed over 3 plus 4x. Negative 2 cubed over 3 plus 4 times 2. Subtract, substituting in negative 2, negative 2 cubed over 3 plus 4 times negative 2. Just do it the math, so negative 8 over 3 plus 8. Subtract. This will be negative 8 over 3, but it's negative, so 8 over 3. Subtract 8. Negative 8 over 3 plus 24 over 3. Subtract 8 over 3, subtract 24 over 3. And keep going. We've got 16 over 3, subtract negative 16 over 3, so 32 over 3, or 10 and 2/3. Okay, and is that the same answer that they had? 10 and 2/3 units squared. Yes. Units squared. Perfect. Okay, so area between two curves. Let's look at another example. Find the total area of the regions contained by y equals f of x and the x-axis for f of x is x cubed plus 2x squared, subtract 3x. All right, so we need to know what this guy looks like. It's a cubic function. We can factor it because there's x in all three terms. Okay, so zeros. So we can't always factor a cubic function with what we know how to do, but in this case we can because there's a common factor. So x cubed plus 2x squared minus 3x equals 0. Take out the common x. And now we might be able to factor that guy. X plus 3, x minus 1. So x equals 0, or negative 3, or positive 1. Okay, so I put those in order, negative 3, 0, or 1. Okay, so that's how we knew that the graph looks something like this. Crossing at 1, 0, and negative 3. All right, so now we know that we can calculate this first area. I'll call that area 1. And then we can calculate this second area. I'll call that area 2. Okay, so area 1 equals the integral from negative 3 to 0 of this function. Okay, and we can do that out. Area 2 is going to be, it's underneath the x-axis, so it's negative 0 to 1 of the same function. Okay, so the total area will be those two things added together, which is what they've done here. Okay, and you can go ahead. I won't go through all the entire steps, but we know how to do that algebra.